Scientists combine actual observations with theoretical predictions that our universe began with a Big Bang 13.82 billion years ago. But what happened before the Big Bang? That question has puzzled scientists and philosophers and people who eat melons for decades. So this time, I will combine the latest advances in cutting-edge physics, discuss what happened before the Big Bang. First, we have to understand the Big Bang itself. The Big Bang theory was actually not very popular with the scientific community at the beginning, because the scientific community at that time believed that the universe was stable and equilibrium, and the volume of the universe has always been like this. It never shrank, it never expanded. Even Einstein thought so at the time. This situation did not change until the American astronomer Hubble discovered that galaxies were moving away from the Earth. Hubble's galaxy is far from Earth. It means that our universe is expanding as a whole. Then, since there is expansion, that means the universe wasn't as big in the past as it is now. So after calculating the speed at which the galaxy is receding to the Earth, Hubble concluded that in the distant past, all the galaxies in the universe are really crowded together. All the atoms in the universe are packed together. And that's at the heart of the Big Bang theory. So with the help of actual observations, the Big Bang theory has officially become the mainstream theory of cosmology. Einstein even asserted that there was no time before the Big Bang. No space. There is no substance. So the laws of physics didn't exist before the Big Bang. The human brain is a product of the Big Bang. We can't see what the universe was like before the Big Bang, just as it is impossible for a person to know his state before birth. And that's not true. Now, there is a theory that our universe is just one of many. In this theory, called the multiverse, countless cosmic bubbles may have been born at the moment of the Big Bang. Every cosmic bubble is a universe. Every universe has its own laws of physics. In our universe, the speed of light is 300,000 kilometers per second. In other universes, it could be 3 million kilometers per second or 30,000 kilometers per second. If the multiverse theory is supported by evidence in the future, then it means that the universe was not absolutely unknown before the Big Bang. The universe at that time was more like a pure energy state, until after the Big Bang. There is also a conversion of energy to mass. As for space-time and matter and the laws of the universe, it all comes with the transformation process. In addition to the multiverse theory, cyclic cosmology is also an answer. The circular universe theory was developed by Hawking's former colleagues, proposed by Nobel laureate Penrose. He thought our universe would go from expansion to contraction at some point in the future. It contracts to the starting point and explodes again. Blow up a whole new universe. So in the circular universe theory, there was actually a universe before the Big Bang. Our current universe, just a product of the last cosmic contraction after the explosion. In the last universe before the Big Bang, there are also a large number of galaxies and stars. There's even a system like the Milky Way and the solar system. There may be intelligent civilizations there too, but they have vanished as the universe contracts and explodes again. All that matter reassembled into the universe and us that we are today. Overall, although there are many theories about the state before the Big Bang that may provide answers, but in actual observation, before the evidence came out, everything is still unknown, and that's what makes the universe so fascinating. More than 30 years after the Hubble Space Telescope was launched, he has photographed many beautiful scenes in the depths of the universe for mankind. Moved tens of millions of light years, galaxies billions of light years away. It's clearly visible in Hubble's lens. However, strangely enough, the Hubble telescope can line up galaxies hundreds of millions of light years away, Why can't you shoot exoplanets dozens of light years away? We can't even photograph the bright stars in the solar system. Many people may find the reasons behind this complex. It involves questions about the laws of the universe. But in fact, the answer is much simpler than you think. Hubble can photograph distant galaxies, but I can't picture Pluto, purely because of the foot diameter of both. Or the diameter is different. Now, you may be unfamiliar with the term angular diameter, but it's what the astronomical community uses to determine the size of the target celestial body. In general, the angular diameter of the moon in our field of vision is about 0.5 degrees. This means that if we divide the 360-degree space on the field of view into 720 equal parts, then the moon occupies an equal part of it. But the moon is 380,000 kilometers from the Earth. With an angular diameter of 0.5 degrees, Andromeda, 254 million light-years from Earth, has an angular diameter of 3 degrees. That's 6 times the size of the full moon. And that's because Andromeda is very far away. But it's 220,000 light-years in diameter, so it was much easier to photograph him with the Hubble telescope than with the moon. Even with hundreds of exposures, and we end up with a multi-gigapixel image of Andromeda. 380,000 kilometers away, the lunar angle is only 0.5 degrees in diameter, smaller than the moon. 480 billion kilometers away, Pluto's angle is only 0.11 arcseconds in diameter. 1 more degree equals 3,600 arcseconds. I don't have to tell you to see how small Pluto is in the view of the Harvard telescope. So it wasn't until 2015 that the New Horizons probe passed by Pluto. Humans just got a high-definition image of Pluto. Before that, Pluto's image has always been a mosaic. Even today, after the SCARF telescope took off, he was unable to photograph Pluto in high definition. Therefore, it is still necessary to send probes to the outer solar system. Our country has this plan. Let's go back to the Hubble resolution. NAPA looks back at the Hubble telescope with current technology. It's still a very sophisticated device. Just the high-precision grinding and polishing of his giant lenses. No other country has been able to do that. The only thing that limits the observational capabilities of the Harvard telescope, only the laws of physics themselves and sharp criteria. The sharpness criterion is actually quite simple. That is, a telescope's ability to resolve the details of a celestial object is proportional to its aperture. The bigger the telescope is, the better the ability to observe tiny targets. The Hubble telescope is only 2.4 meters in diameter. If it is 24 meters or 240 meters, the observation ability is different again. However, due to the Earth's gravity and environmental factors, astronomers are actually rather pessimistic about the future of giant optical telescopes. Because space is the best place for telescope processing. Humans are unlikely to have the ability to build industrial systems in space anytime soon. Therefore, super telescopes hundreds of meters in diameter or even larger may not appear until the 22nd century. But telescopes are not just optical telescopes. Now scientists have proposed an attractive force telescope based on Einstein's general theory of relativity. This is a warping of the fabric of space-time based on the Earth or solar energy. A telescope set up to zoom in on distant targets. In theory, just find the focus point and distance. Humans can directly obtain a telescope the size of the Earth. His resolution will be enough to allow astronomers to see the surfaces of exoplanets in nearby star systems. For a long time in the past, humans believed that the Earth is at the center of the universe. All the other celestial bodies revolve around him. However, is that really true? In the 17th century, Galileo proved through telescope that the Earth is not the center of the solar system. and he saw that Jupiter had moons. As the moon revolves around the Earth, Jupiter's moons are also orbiting the magic star. Now we know. The Earth is not the center of the universe. It's not even the center of the solar system. The Sun itself is the center of the solar system. There are currently 8 planets and various types of small bodies orbiting the Sun. The Earth is only the 3rd closest planet to the Sun. The closest to the Sun is Mercury, then Venus. Then came the Earth. It takes 365 days for the Earth to complete 1 revolution around the Sun. His average distance from the Sun is 150 million kilometers. This distance is known in astronomy as the astronomical unit. Light 300,000 kilometers per second takes about 8 minutes and 20 seconds to travel that distance. Now let's start moving towards the outer solar system. Between the orbits of Mars and Jupiter, we're going to encounter the asteroid belt. They range in diameter from a few kilometers to hundreds of kilometers. 750 billion kilometers from Earth. It is the last planet on the edge of the solar system at this stage, Pluto. From there, looking back at the solar system, you can't see the Earth at all. The Sun is just a dim bright spot. Leaving the solar system and entering the stars, the first exoplanet we went to after space was Proxima Centauri. This is the nearest star to Earth. It's only 4.2 light-years away. That's more than 4 years at the speed of light to reach Proxima Centauri. In comparison, Voyager 1 will take 70,000 years to reach Proxima Centauri. The solar system and Proxima Centauri are both part of the Milky Way. It's a collection of hundreds of billions of stars bonded together by attractive forces. Appears as a flat disk. The center has a bright core. The stars there are very powerful, and it also harbors a super black hole, 4.40 million times the mass of the Sun. On the scale of the Milky Way, light years is not enough. Astronomers began to use parsecs as a unit of distance. A parsec is 3.26 light years. The Milky Way is at least 30,000 parsecs across, which is 100,000 light years. This means that if there is an advanced civilization in the galaxy that is more advanced than humans, their light-speed spacecraft will take 100,000 years to cross the galaxy. It's surrounded by spiral arms. There's a ball of corn around the core. It extends beyond the Milky Way galaxy. At this point, for example, a new unit of measurement is 3.26 light-years. To measure the size of our Milky Way galaxy may be faded, so the diameter of our galaxy is about 30,000 parsecs, equivalent to 100,000 light-years. So if we go back to the millennial depletion again, and must travel through the galaxy at the speed of light, same side to other side. Even if we travel at the speed of light, it would take 100,000 years to travel across the galaxy. Similar to Earth, the 3rd planet in the solar system from the inside out. And the solar system, more or less in the Milky Way, is on a wall around the 3rd ring called Orion. Travel from the Sun to the center of the galaxy requires flight 26,000 light years, and the Sun takes 250 million years to circle the center of the galaxy. Considering the Sun was only 460 billion years old, so according to the painting of the Milky Way Chronicle, the Sun is actually only in its 20s. In the current division, the Milky Way and Andromeda galaxies, together with more than 70 other galaxies, form the local group of galaxies. It's about 10 million light-years across. Several groups of galaxies will form part of the galaxy cluster, and then the Virgo supercluster, 110 million light-years in diameter. Astronomers currently believe that there are at least 200 billion galaxies in the observable universe. On average, there are 200 billion stars in each galaxy. And I don't need to tell you how small the Milky Way and the solar system and the Earth are in space. In general, Our Earth is not the center of the galaxy. It's not the center of the universe. It's just a planet orbiting a yellow dwarf. In Carl Sagan's words, the Earth is just a speck of dust suspended in sunlight. Einstein's theory of relativity is one of the two pillars of modern physics. It's not that complicated. Now I will use the simplest language to popularize science for you. The story begins when Einstein was young. At that time, he became a civil servant after graduating from college. In my spare time, I like to think about physical problems. One day when he was riding the tram to work, he imagined that if the tram reached the speed of light, then it seemed to him that the hour and minute hands on the clock would stop moving. At the same time, for people at normal speed, time didn't stop there. This thought experiment made Einstein realize, as a person moves through space at an increasing speed, time goes by more and more slowly for him. So here's the question. If time in the universe is a constant physical quantity, why does speed affect time? Einstein first studied what Newton and Maxwell had to say about this. Newton first believed that speed is relative, but Maxwell thought the speed of light was constant, not relative. That means the relative speed of the two beams is still 300,000 kilometers per second, instead of 600,000 kilometers per second. We can clearly see Newton and Max had a conflict over speed. So Einstein thought that time could be stretched or compressed as it moves through space. This is the later expansion of time in special relativity. In the later general theory of relativity, he also proposed that time should be a dimension of the universe. Time and space are both part of the universe and the concept of four-dimensional space-time. In four-dimensional space-time, massive objects like the sun and the earth warp the surrounding space-time. So it's like putting a bowling ball on a box spring will dent the box spring. Then let the objects around the bowling ball rotate and fall close to the bowling ball. The moon begins to orbit the earth. The earth begins to revolve around the sun. The sun begins to orbit Sagittarius A7, the supermassive black hole at the center of the Milky Way. And because the planets move through space, time is relative to your own time. So the more attractive force the planet, the slower time goes by. Black holes are the most attractive forces in the universe. Nature can seriously affect the speed of time passing nearby. Therefore, in interstellar travel, there is a plot that 1 hour near the black hole will pass 7 years on Earth. Although time dilation is still far from practical application, but the time difference has been calibrated using the time dilation formula on high-speed navigation satellites. Otherwise, the time on the satellite will be slower than the time on the ground. This in turn affects navigation accuracy. As for the warped space-time in general relativity, even further away for the current stage of human civilization. However, the scientific community is still based on the properties of space-time revealed by Einstein's general theory of relativity. Hyperluminal spacecraft based on curvature drive and wormholes based on space-time folding are imagined. They can travel tens of millions of light years in a short period of time. Overall, although relativity is still an esoteric theory for most people today, but as time goes by, it's going to be something as fundamental as Newton's teaching of gravity. Relativity could be taught to every 22nd century schoolchild. But relativity is not a perfect theory either, because another pillar of modern physics, quantum mechanics, says attractive forces come from the exchange of attractive forces, rather than the so-called space-time warp. This leads to a contradiction between relativity theory and quantum mechanics. Therefore, there must be a new theory that unifies relativity and quantum mechanics in the future. Have you ever considered, what is the essence of time? Mark Twain once said that time is the thing that prevents everything from happening at the same time. He compared yesterday's events with today's. Today's events are separate from tomorrow's. So when you watch this video here, you are not yesterday nor tomorrow. It's moving from one second to the next. Moving forward on the arrow of time. Everything in the universe, including you, is moving towards tomorrow under the arrow of time. However, Einstein believed that, although all objects are moving towards the future, but the speed of time loss is different for each object. Specifically, the faster the object, time slows down. This phenomenon is known as time dilation. Will cause objects traveling at the speed of light to stop the passage of time. For example, if I could travel 254 million light-years to Andromeda right now, then in the eyes of people on Earth, it'll take me 2.54 million years to get to Andromeda. But in my own feelings, it's an instant in Andromeda. Didn't experience the passage of time at all. It's because I've reached the speed of light. Time stands still. While the Earth world is still moving at low light speed, the speed of time has not changed. In addition to speed affecting time, Einstein proved it in general relativity. Attractive forces also affect the speed of time. Specifically, the closer you get to an attractive force, the slower time is for you. Experiments on the theory of justice were conducted as early as 1959, when scientists fired gamma rays at the surface from the tops of skyscrapers. And we measured the change. It was eventually found that the frequency of gamma rays increased at the surface. This is the time change caused by the attractive force of the Earth. That is, the Earth's attractive force on the surface is stronger than the Earth's attractive force on the roof. In this case, astronomers have discovered if someone lived on Mercury, then every 2 years he will be 1 second more than the Earth. This is because Mercury is closer to the Sun, a more attractive force, and the place in the universe where you can really feel the obvious phenomenon of time inflation. Only near supermassive black holes, in front of black holes with masses and hidden intensities equivalent to billions of times that of the Sun. The speed of time will approach zero. That is to say, if you spend an hour near a black hole, decades may have passed on Earth. The so-called Fang 1 day in the cave. It's been 1,000 years. In fact, after careful moxibustion, we will find that time dilation effect in our country's ancient myths, they're everywhere. The most typical example is a year in the sky. Explain it with current scientific theories. The mythical heavenly court is actually a near-light spaceship. Because of the time dilation caused by high-speed flight, to realize the passage of time 1 day in the sky and 1 year on Earth, metaphor. If you go further, the meeting of the 7 cowherd and weaver girls every July is actually a daily occurrence for the weaver girl, because in the case of 1 day in the sky and 1 year on Earth, if calculated according to the Earth year, the weaver girl stays in the sky for 365 days. 365 years on Earth? That's obviously not realistic. So the real cowherd and weaver girl meet. It must be the celestial calendar. In this case, weaver girl meets on July 7th of her first year. The day after we separated, we went back. Another year has passed on Earth, and on July 7th of the following year, the cowherd and the weaver girl meet again. In general, although Einstein proved the difference in the speed of time, but for human civilization that cannot even reach 1/10 the speed of light at present, they don't experience time dilation. So in the future we can meet. Many phenomena in relativity are still at the stage of small-scale verification and can't be really used by humans. The Earth under human feet, it is the only known planet in the universe where life exists.
However, when we look up at the stars,
you will find that the Earth is just a speck of dust in the universe. So next we're going to start from Earth. Travel to the edge of the universe, towards an endless universe. Explore the distant stars. Earth is the third planet in the solar system, born about 450 billion years ago, under attractive force, formed by swirling gas and dust clumping together. Since then, the Earth is always changing. However, when we leave the Earth, enter the empty universe and you will find the solar system is just one of the countless star systems in the universe. The only thing that's a little bit special is that the solar system has 8 stars. Other star systems usually only have 1 or 2. In science fiction movies, human spaceships could reach distant planets in a day. However, in the real world, it will take us half a year to reach Mars. Whether it is 150 million kilometers from the Sun to the Earth, or 4.2 light years from Earth to Proxima Centauri, that's out of reach for us at this stage. Far beyond the limits of human lifespan, it's a meaningless goal. However, the Sun and Proxima Centauri are just 2 of the closest of the 100 billion stars in our galaxy. In a galaxy 100,000 light years in diameter, even at the speed of light, it would take us 100,000 years to cross the galaxy. Not to mention going to Ceres 254 million light years away to be stars. Observations with the Hubble and Webb telescopes have confirmed, whether it's the Milky Way or Andromeda, are just ordinary beings in the observable universe. With at least 2 trillion galaxies in the observable universe, 93 billion light years in diameter, the Milky Way is a drop in the ocean. Astronomers also pointed out that the current observable universe, 93 billion light years in diameter, is only the observable universe of mankind. That is, one centered on the Earth, a sphere with a radius 4650 billion light years. And there are plenty of galaxies out there. But since the speed of light is only 300,000 kilometers per second, and space-time is expanding faster than light, so light from galaxies 4650 billion light years away can never reach Earth. In this case, even if an alien civilization lives 4650 billion light years away, we can't know. The largest structure in the observable universe is the Great Wall 400 million, is a supercluster of galaxies, and the Great Wall is a fibrous structure of tens of millions of galaxies. And at their central intersection is the supercluster. For example, the Virgo supercluster, where the Milky Way is located, and the feathery Laniakea superstar cluster. It's a typical cosmic Great Wall node. They usually have 100,000 galaxies inside them. Scientists use Einstein's theory of general relativity. They thought the universe should be bounded and boundless. In other words, at the speed of light, you will eventually return to the starting point, just like Magellan's circumnavigation of the world. However, for the current stage of human civilization, the speed of light is too far away. At least in the next 500 years, human civilization cannot travel the universe at the speed of light. In general, although the universe is large, but what is really relevant to human civilization is this place in the solar system. A much larger galaxy would not have intersected with human civilization. So we don't have a lot of resources. There are hundreds of planets and satellites in the entire solar system. Enough for human civilization to squander for tens of thousands of years. When you look up at the stars, you might think the universe must be teeming with stars and galaxies. But in fact, there are many galaxies in the universe. But galaxies are usually separated by vast distances. When galaxies are too distant from each other, would create a region of the universe that is almost completely dark and empty. These regions are what astronomers call cosmic voids. There are about 100 galaxies in the local group, dominated by the Milky Way and Andromeda galaxies. That's not enough to make a hole in the universe. The previous episode of the local cluster contains thousands of galaxies. They are equally distributed under attractive forces. The real hole in the universe is the Virgo supercluster above the local cluster of galaxies. A supercluster, consisting of several clusters of galaxies, often contains tens of thousands of galaxies of the size of the Milky Way. They're tens of millions or hundreds of millions of light years across. In this case, the attractive force is no longer enough to keep the supercluster uniform. They form spider web-like structures with dark matter and dark energy. And the cosmic hole is the region between two adjacent superclusters, the gap in a spider's web. Astronomers currently believe that, if we look at the universe as a whole, galaxies are atoms. And the atoms, for the most part, are clustered together or the silk into the spider web structure. So empty spaces where atoms are sparsely distributed. It's not really true that they have nothing inside, because the empty space is still 1/10 as dense as the rest of the universe. It's not that there are no galaxies at all, just too few, not much light. The largest hole ever discovered is the Hercules superhole. It's about 33 million light-years across. If the Milky Way is located in it, human astronomers might now think that the universe is 33 million light-years across. The Milky Way is the only galaxy among them. It's not what most people think. The existence of empty space is by no means simple existence. It's also influencing the evolution of the universe, because astronomers have discovered that there's a lot of dark energy in voids. And this dark energy accounts for up to 70% of the total intelligence in the entire universe. This means that cosmic voids have been accelerating the expansion of the universe. The density gets lower and lower over time. And the direct consequence of that is that more and more galaxies are emitting light from the Earth. Completely lost contact with Earth beyond the cone. We're going to see fewer and fewer galaxies. The future, as the expansion of the universe accelerates, even the stars in the Milky Way are moving further away from Earth. The stars in the night will be extinguished one by one, until there are only a few planets left in the solar system. As the main force behind the expansion of the universe, some astronomers even think that the empty space will eventually expand into the entire universe. When all matter is torn apart by the forces of cosmic expansion, the voids in the universe will merge into one superhole. Nothing inside. Even photons don't exist and can't fly out. Some people will say, "Isn't that a black hole?" Yes, there are theories that our universe is a black hole. We live inside a black hole. It's just that this black hole is too big. We don't feel an attractive force. In general, supervoids are the largest single structures in the universe. Their existence reveals the complexity and diversity of the universe. If in the future humans can send probes into the nearest cavity or directly penetrate it, the understanding of dark matter and dark energy will take a leap to the next level.